Hi everyone, today we're going to cover our last lesson of the unit and it's on applications of linear relations. So let's say you're visiting Montreal and a taxi company charges a flat fee of $5 for using the taxi and then $1.25 per kilometer. We're going to make some calculations with this information. So first of all, how much would a ride for 15 kilometers cost? So I'm going to use this variable C to represent cost, and I know that it's going to be a $5 flat fee plus $1.25 per kilometer. And if I have 15 kilometers, my equation is going to look something like this. So I am going to get 1875 . Okay, so it costs $23.75 to travel 125 per kilometer. Sorry, to travel 15 kilometers. Okay, so how would I figure this out if I know that the ride costs $25? Well, if I know my flat fee is $5, I know that I've paid $20 on kilometers only, right? And then what I can do is divide the 20 kilometers by the cost per kilometer, and I'll get 16. So I know it was 16 kilometers, but I want to come up with, instead of doing this, we call this a calculation. A calculation is different than an equation, solving an equation, because a calculation doesn't contain any variables. So in this unit, and in fact in all of our units, we prefer it if you use an equation with variables. So what we want to do is create an equation. If x represents the number of kilometers driven, write an equation for the cost of a taxi. So what we can do is realize that the cost of the taxi is $5 plus 1.25 times x, and then I can sub in a number for x. It looks a lot like the equation we used in or the calculation we made in our first question, but now I have a variable x. Now I just want to rearrange this for a minute in this form, because I'm hoping that you will notice that this forms the equation of a line, y equals mx plus b. And if you think about it, if I were to quickly sketch this out, okay, so if I were to quickly sketch this out, I would see a y-intercept at 0.5, and then I could look at my slope as 1.25. Another way to write 1.25 is 5/4. I don't expect you to know that, but I'm just making a point here. So I know that my slope is going to be, 5 units over 1, 2, 3, 4, 5. 1, 2, 3, 4. Sorry. I can see that my slope is 5/4. What that means is a rise of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Not that I expect you to know that, but what I'm trying to get at is that the equation for cost takes on the form of a line where the y-intercept represents my flat fee in this case, $5, and then the increase, the rise and the run, are based on the rate per hour. Okay, and we can see that yes, it is a linear relationship, and I know this because of the rate of change, or the slope, and also, really, I know it because it takes the form y equals mx plus b. So what I want us to make note of, and I'm going to just put a box in here, okay, is that when we have scenarios involving an initial point and a constant rate of increase or decrease, we can write this scenario, write an equation for, I should say, write an equation to describe this scenario. And it has the form y equals mx plus b. We can also use y minus y line. Okay, but in the y equals mx plus b form, I know that b is my initial value. Okay, that's my initial value. And m is going to be my rate of change, rate of increase or decrease. Okay, let's just do some practice writing out equations. So if I rent a bicycle for $20 plus $2 per hour, I have to let h represent number of hours, and my total cost is going to be 20 plus 2h, or 2h plus 20. So I preferred if we write it in the equation of a line y equals mx plus b. An auto repair shop charges $50 plus 25 per hour. I'm going to let h represent number of hours. Okay, and then my total cost at this auto repair shop is going to be 50 plus 25 each. Okay, this one is a decrease. A candle that starts at 6 inches tall and burns at a rate of 2.1 inches per hour, which means it's getting smaller. What is the candle's height? H. So in this case, let's let T represent number of hours. Then the height is going to be 6 subtract 2.1 t, or we can write it as negative 2.1 t. So I can see it has a negative slope. It'll be sloping downwards. Okay. The temperature is 15 degrees, and it's expected to fall 2 degrees each hour during the night. Let h represent the number of hours. Okay, and the temperature T is going to be 15 minus 2h, or negative 2h plus 15. Okay, so number 5 is a bit different. In number 5, it says the cost for 7 dance lessons is $82. The cost for 11 dances is $122. Now we're assuming it's linear because we're in the unit on linear relations, or we're on the lesson. So we can assume that this relationship is linear. If I were to basically think of this as a line being plotted, I can see that for 7 dance lessons, the cost is $82. Okay, I'm just sort of visualizing this. This is not to scale by any means. And at 11 classes, I'm going to have $122. So we can think of these as coordinates. So what I need to do then is I need to figure out the slope, okay? And I'm going to use y minus y line equals mx minus x line for this equation, okay? So first, we know that the slope here, and it is linear, can be calculated using y2 minus y1 over x2 minus x1. So I'm going to get 40 over 4. So I can see my slope is 10, and it is increasing, so that makes sense. And now what I'm going to do is sub that into y minus y line equals mx minus x line, which I like to write in pink here, just to remind us it's a very common formula. So what I'm going to do is sub in either 782 or 11,122. I'll just sub in the first one. X minus 7. So I get y equals 10x minus 70 plus 82. Y equals 10x plus 12. So what we're saying here is that the cost is 10x plus 12, where x is represent the number of classes. Okay, so think about this in the following way. Number 5, I'm giving you 2 points of the line, and you have to find the equation that represents the relationship, whereas number 4 gives me the slope and the initial value, so the rate of change in the initial value. So for numbers 1 to 4, I can use y equals mx plus b, but for number 5, I had to use y minus y line. Okay, let's put this into a bigger scenario that would probably make more sense in real life to you. So a plumber charges $50 to take a house call. He charges $25 an hour for labor. Let's write an equation that I can use to determine the plumber's total charges based on the number of hours of labor. So what I'm going to do is let H represent number of hours of labor, and the cost for this plumber is going to be $50 plus 25H, okay? Let's rewrite it like this, 25H plus 50. Okay, how much would it cost for a house call that requires 2.5 hours of labor? So I know H is 2.5. I can just substitute that in for H. Okay, so my labor itself is going to cost $62.50, and then the flat rate fee for showing up is $50, so this is $112.50. It costs $112.50 for 2.5 hours. Okay. C, if the bill is $162.50, how many hours did the plumber work? Well, now I actually have the cost, and I want to solve for H. So I can just sub C equals 162.5 into my formula. So I get 162.5, subtract 50, 112.5 over 25 equals H. H is 4.5. The plumber was there. The plumber worked for 4.5 hours. Okay, so in the last one, I want us to graph our equation, and this is the first time where the axes are not given to you. So you have to actually label them. So if I know that C equals 25H plus 50, okay, I know my numbers have to be kind of big, okay? So my y-intercept is 0.50, so let's put it here, and I don't know, maybe here. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. Okay, why don't we go up by we'll go up by 5s. Okay, so this is 5, 10, 15, 20, 30, 40, 50, and I know that's where I start. Okay, and I know my slope is 25, so maybe what we can do is, which means my rise is 25 when my slope is, when my number of hours is 1. So why don't we do this? 1, 2, 3, 4, 5, 6. So if I go over 1, I should be going up 25. So 10, 25. Sorry. When I go over 1 unit, 10, 25. So that'll be my next. This is 1. This is 25. 1, and then 5, 10, 25. Okay, I probably could have done a better job with this, but you get the point. So, no pun intended. So here we go. We're going to draw this line in. Okay, and now we have to answer a really important question. In what quadrants does this graph make sense? So you have to think about what these axes mean, and maybe let's label them. So this is going to be hours, and actually we should label them, and if you ever get a graph like this, you will have to label them. So I have hours, and then I have dollars, right? Now, if you'll notice, this is quadrant 1, and in quadrant 1, both hours and dollars are positive. And if you really think about this, it doesn't make sense for either of these two quantities to be positive. So if I'm going to graph this properly, what I'm going to do is erase this line and realize that it can only exist in the first quadrant when x and y, or h and c, this is h actually, and this is c, are both positive, okay? So this question is very important. It only makes sense in quadrant 1, okay? Next question. Jim has to choose between 2 gym membership plans. Plan A is $50 monthly plus $10 per visit. Okay, and Plan B costs $25 monthly. Sorry, monthly one-time membership fee and $15 per visit. This wording is weird. Let's get rid of the one-time. Okay, so this is what that means. So if we let x represent number of visits, okay, cost A, I'll just make it a little subscript A, is going to be 50 plus 10x. Cost for gym B is going to be 25 plus 15x. So we've created an equation for each plan, and now I want to graph each equation. So I'm going to realize that before I even go to plot this, the only quadrants that this makes sense in is Q1, because number of visits has to be positive, and also money has to be positive in this case because it's being paid. Okay, so I can see that the first one, okay, so now I can go right to the corner with 0, 0, 0, 0. So I'm going to say number of visits. And here we can have cost. And maybe I'll go up by tens this time. Okay, so we've got 10, 20, 30, 40. Oops. Okay. It's 100. You don't have to label them all, so let's just, once I know what one box is, let's leave it there. And then I'll do visits. I'll make them a little bit more spread out. Okay, and how did I know that? Because I can see the slope is 10 over 1, and here the slope is 15 over 1, right? So I'm going to do plan A in blue. So we're going to start at $50, and we're going to go across 1 and up 10, across 1 and up 10. Okay, and I can see that although on this grid it looks like the slope is 1 over 2, when I look at the units that I've put on the bottom, okay, it's actually 1 over 10. Okay, so if I join that with a ruler, it should look pretty good. I'm going to do, so this is plan A. That has equation CA is 10x plus 50. Now let's do plan B in purple, and I'm going to start at 0.25. So I know I'm on a half square, but that's okay. And I know my slope is 15 over 1, so I'm going to go 1 across, and I'm going to go up 5, 10, 15. 1 across, 5, 10, 15. 1 across, 5, 10, 15. 1 across, 5, 10, 15. 5, 10, 15. 5. Okay, this one's a little more awkward. I think I have enough dots there to make it look pretty good. All right. Nope, I think I messed something up here. Right here. All these ones are off by a half. All right. And notice how I didn't notice that something was off until I tried to join it with the ruler. So ruler is good. All right, so I can see here that there is a point of intersection, which is really what I'm trying to get at here. Okay, so what is the point of intersection? So we can see here that the point of intersection is 5, 100. And so that what that means is at 5 visits, the cost is going to be $100 regardless of whether Jim goes to plan A, Gym A, or Gym B. So the point of intersection in this case is, I'm going to write this out, for 5 visits, the cost is the same at both gyms. Okay? So let's move on to the next example. In the next example, the math department is sponsoring a math family fun night. In the first year, there were 35 participants. In the third year, there were 57. Graph the 2 points and join them on the grid. In what quadrants does the graph make sense? So, first we have to make a decision here. I would recommend that in the first year, before we plot it, let's make a table. So in the first year, I'm going to actually call my x value 0. So that's going to be year 0. I'm going to think of it as an initial value. There were 35 participants. Then we would have the second year. We don't have any info on the second year, but we also have our third year. So our third year would actually have an x value of 2. Now, the reason I'm doing this is because I want to make this my y-intercept. It's helpful in drawing the drawing the graph, but also the y-intercept then will have a meaning to it. It will be our initial value. Okay, so we're actually going to join these 2 points on the grid where the first one is 0, 35 and the second one is 257. Okay. So I think we should go up by 5s. So this here would be 10, 20, 30. Okay, so I have 0, 35, which would be right here. And then I have 257. So let's call this 0, 1, 2. So 2 would be, this would be 55, and let's go up a little bit more, 57. Okay, in what quadrants does the graph make sense? Well, I think it would be pretty obvious that it only makes sense in Q1, where both time and participants are positive. Okay, so let's write the equation to predict how many participants there were in any given year. So the first thing I'm going to need is the slope between these 2 points, 57 minus 35 divided by 2 minus 0. And now I can start with y equals mx plus b if I want. This is method 1 from that lesson. And then I'm going to sub in a point. Excuse me. Or actually, I don't really have to, but because I know what the y-intercept is, the initial value, I probably didn't actually have to solve for b, but there we are. It looks like something got cut off here. So let's just say how many participants are predicted for the 5th year. I think something got cut off in my notability notes. So in year 5, or the 5th year, my x value would actually be 4, okay, if I go by the pattern in the table. So what I would do is sub in 4 for x, and I would get 44 plus 35 is 79. There are 79 participants. Participants in the 5th year. Okay, last one. We have 2 rules. To get y, you double x and add 1. Rule 2, to get y, you have x and subtract 5. Okay, write an equation for rule 1 and graph it. I'm going to double x and add 1. Might as well do b at the same time. X over 2, subtract 5. So let's graph these. All right, 2x plus 1. And x over 2, subtract 5. 1, 2, 3, 4, 5. All right. Okay, what is the POI of lines 1 and 2? I can see that the point of intersection is 1, 2, 3, 4, negative 4, 1, 2, 3, 4, 5, 6, 7, negative 7. The POI is negative 4, negative 7. What does it represent? Well, it represents where the point that follows both Rule 1 and Rule 2. Okay, so that one particular point is both when you double x and add 1, you get y. So let's actually try it. So if x is negative 4, if I double negative 4 and add 1, I get negative 7. And also, if I half negative 4 and subtract 5, I also get negative 7. So this one point follows both rules. And in what quadrants do these graphs make sense? Well, I think I can see that they make sense in Q1 all the way to Q4. So the point here is that the negative x and y quadrants also work because these are just rules for numbers. They're not like time or age or money, so they don't have to be positive, and they do make sense in the negative quadrants. So now your job is to try the homework, and if you have any questions, as usual, please see us in extra.